Hello and welcome to this Houdini tutorial on how to create procedural snowflakes. So I have not had to model any of these. They're all procedurally done with either noise, which is something like this. So slightly less realistic, but very interesting to look at. And then the second method I'll be showing you how to make uses an LSystem based approach, which creates shapes that you probably recognize a bit more when you look at macro footage of snowflakes. So like I said, this is entirely procedural. This is the setup that essentially generates our snowflakes. So if I was to visualize just one of them, you can see the snowflake here. However, the real beauty of this setup is that we can feed it as many points as we like. And for every point that this setup gets fed, it will vary some attributes. And I'll be showing you how to do this, i.e. the noise offset or the type, and it will then produce an entirely unique snowflake for every time that this setup is run. So here I have 7 points, which I'm going to feed into this setup, and as you can see, we have 7 completely unique snowflakes. So now I'm going to feed it 64 points, and as you can see, we have 64 completely unique snowflakes without having to do any hand modeling. Next, I'll be showing you how we can do a very quick Popsim that gives us behavior that's typical of snow falling. And then finally, I'll be showing you how we can then instance our snowflakes that we generated onto these points to create this final snowflake scene. Let's jump right into it. All right, so starting off with an empty scene as always, first thing we're going to do is drop down a geocontainer, which I'm going to call snow. So the first thing we're going to do is create one procedural snowflake. To do that, I'm going to use a circle node. So the first parameters we're going to change is the primitive type, which we're going to set to polygon, and then the orientation we're going to set to Z and X. Then if we set the arc type to sliced arc, and because I have wireframe on, which you can enable here, smooth wire shaded, you can see that we now have segments. So the idea with this setup is that we're going to cut out our unique shape, a bit like if you were making a paper snowflake. You would fold up your paper into one triangle, you would apply your cutout shape, and then once you unfold it, you have a repeating pattern. So we are just going to apply that same logic to this. So if I reduce the division size to something like 8 for now, just to keep it simple, we are going to keep one of these segments. So to do that, I'm going to use a blast node, and I'm just going to keep primitive 0 for now. So if we put 0 in the group and tick delete on selected, we have one triangle. Then if I remesh it, we can then give ourselves some more topology to work with. So I'm just going to decrease the target size now to something a lot smaller. And we can always decrease this later if we want higher detailed snowflakes. The next node we're going to drop down is our attrib noise. If we visualize that, we can start to see that it's applied some random color. We set it to float. It's just going to quickly set it to black and white. At the moment, you may be wondering why the top is blue and the underneath is grey, and that is because we have, by default, if we hit D and our display options come up, we have tint back faces. At the moment, since the normals are actually pointing down, that's giving us a blue indicator that we are actually looking at the underneath of this polygon. We can simply just untick tint back faces, and as you can see, both sides are now grey, and that helps us visualize our color better. At the moment, we're not really seeing much detail out of the noise. So first thing I'm going to do is just change our noise type to Whirly Cellular Manhattan, FT-F1, which is just a noise type that I liked, but you can pick a different one. And then if I enable the remap ramp, then it gives us the ability to play around with the noise to kind of make it a bit more crunchy. I found that inverting it by hitting this button and then just bringing down this top slider gave me some shapes that I felt looks quite interesting as a snowflake, kind of these cellular branching shapes. Next, we can play with our element size. I think I reduced it down to something like 0.8. And then finally, I'm just going to tick post-process minimum and maximum just to make sure our values aren't exceeding those boundaries. Next, we're just going to set the attribute class on our noise to primitive. And the idea is that we're going to cut out anything that's below a certain threshold to leave us with some interesting patterned shapes. So if we jump down a blast node, we can then, inside this group box, we can use @cd less than 0.2. So we're essentially blasting away any shapes that are less than that value. And then, much like the kaleidoscope, if you've watched those kaleidoscope tutorials, we're going to drop down a mirror, set the direction to be 1 in the Z. So we've essentially flipped it. Then we can use our copy and transform node to finally clone the shape round to complete our snowflake. So this rotate value is going to be 360, which is a complete circle, divided by the amount of divisions that we have, and then times 2, since we've already mirrored it once. Then our total number we can also do procedurally, which is going to be 360 divided by the value of this rotate parameter here, base relative reference. So as you can see, we now have our very basic procedural snowflake generator set up. If I was to play with the noise settings here, like the offset, you can see we can just very quickly get some procedural interesting shapes. Now we're going to give our snowflake a bit of thickness. So to do that, I'm going to use the extrude node, poly extrude, and we're going to set divide into to be individual elements. Then if we just add a bit of distance, our normals are pointing down, so positive values are going to go down. So just to counteract that, I'm going to use negative distance values, something like that for now, just to see what we're working with. And the next thing we're going to do is tick output back. So this has given us an overall thickness. However, it'd be quite nice if the darker areas, i.e. the edges, were not as high as the inner parts. And to do that, we can use local control, which by default, this distance scale is looking for Z scale. But if we give it our CD attribute, you can see now we are using our colors to control how high each tower is going to go. So if we visualize this copy again, you can see we have our extruded snowflake in one axis, and then simply to get it going in both directions, we're just going to use another mirror, which we can set the direction to 1 in the Y. Now we have our very basic extruded snowflake. There's a few things we can do to now clean up our snowflake geometry, and one of the nodes I probably would recommend to do that would be one of the labs tools, which is voxel remesh. If you can't see this node, then make sure you're using one of the latest versions of Houdini, and if you just enable this side effects labs shelf, ticking it here, you can then hit update toolset and you should get access to all of these nodes. So voxel mesh, so by default it's going to make our entire shape black, and to fix that we're just going to add some color, white, just to see what it is. So this has kind of made it one continuous mesh. We can also potentially turn on project to original, which is just going to crispen up some of those edges, maybe even ticking sharpen feature if that's what you wanted. I'm just going to leave it just slightly more rounded. If you're wondering how you might be able to procedurally delete any shapes that aren't attached to the main body, like you can see these little bits are floating, then another labs tool I would recommend would be delete small parts. And if you plug that in, we can then change this to extract largest piece. And as you can see, it's deleted those smaller shapes. So this is a noise-based approach. If you're looking for something that resembled more of a classic looking snowflake, then we can use an LSystem for that. So I'll show you how to do that now. First node we're going to drop down is LSystem, which saves us a lot of time. And by default, it's going to give us this rough looking tree. If we hold down this cog, it gives us a bunch of presets which you can cycle through. I'm going to be using 2D plant D. Now we're just going to lie down this tree so that it lines up with our segment that we have here. So we're going to be using a transform node. And if we rotate it around 90 and then lay it flat that way. Now we can use a node called match size, which is going to, as you probably guessed, match size. So we can plug the second input into our arc and we visualize it. We want to enable scale to fit, and we're going to set our justify x to min and then the other two to none. So then, as you can see, it's lined up nicely with our arc here. Next, we're going to be using an attrib transfer just to transfer over this pattern. So we can drop down a color node here, leave it to white. We can then drop down another color node and plug it into our remesh and set this one to black. Make sure it's plugged into the remesh and not the attrib noise. And the first input is going to be the arc, black arc, and the second one is going to be our LSystem. And if we visualize that, at the moment the whole thing is white. We just need to bring down this distance threshold. Before we do that, if we go over the attribute section, just make sure we're only transferring over CD. And then in our conditions, we can bring down our distance threshold to something really small, like 0.15. If you wanted a bit more resolution, we can just bring down our remesh target size to something like 0.15, and you can start to see that shape a bit more clearly. Now we're going to use an attrib promote just to put that color information onto the primitives instead of the points. So by default, the original class is point, new class is going to be primitive, and we are looking for CD. So as you can see here, it's promoted that. And then if we plug it into the rest of our network and visualize the end, we have our classic looking snowflake. All right, now that we have our two different ways of creating a procedural snowflake, I now want to be able to run this multiple times so that we can create a stack of snowflakes for us then to instance onto our snowy points that we'll make later. So to do that, we're going to be using a for each loop, for each point specifically. There's a few different ways we can do this, but I'm going to be using a copy to point. So the first input is going to go into our snowflake generator setup, and then the second is going to be here. For now, I'm just going to be using a add, and then in this add, we're just going to tick so that we have one point being fed into our setup. And then if we visualize the end, you can see that we have one snowflake being generated. If we wanted to increase this, I'm just going to add another point here and then just offset it slightly. You can see we now have two snowflakes being generated. However, they are identical. So the next step would be to randomize a few different parameters within this setup based on the point number that we are currently iterating on. So to do that, the first thing we're going to do is press create meta import node, which is going to give us this node here, which allows us to access detail attributes such as the iteration number, which is useful because we're going to use the current iteration number, i.e. the point that we're on, to randomize an attribute here. First attribute we're going to randomize is going to be using this noise-based approach that we built earlier. And the easiest one would be this offset, which if I change here, you can see randomly offsets this noise. So we're going to be using a bit of an expression here, vex expression. And we are going to be using detail to access this detail attribute iteration, which has been created. So detail, open brackets, and then we are going to look for that meta import node. And then we are looking for that iteration number. And then simply 0 as the last input. So currently, that is just feeding in iteration as is. If you wanted to control that, then you could always wrap this around a fit. But for now, I'm just going to leave that as is because we're already getting some unique snowflakes here. So if I was to add another point, you can see we now have 3 completely unique snowflakes because we have fed this setup 3 points. The next step would be to then randomize this LSystem based setup that we've got here. And something I found that was quite good to randomize would be this generation number. So if we visualize our LSystem setup, you can see this is what we currently have. Then if I was to lower this generation number, it should make this shape slightly more simple. So we put it to something like 3. And you may notice that you're just getting points, and that's because we currently don't have enough points on this geometry here. That's transferring over to the mesh. It's leaving us with lots of blank spaces. So to fix that, we can just drop down a resample here. And then I'm just going to decrease this length so we get more points along our branches. Something like that. And you can see now that we're able to see that shape. So this generation number we're going to control based on the iteration. However, I'm going to use iteration as a random seed. So the first thing I'm going to do, just to save us a bit of time, is just copy this, which is accessing that current iteration number. I'm going to paste that in here. I'm going to wrap this around a rand function, which is going to give us a random float between 0 and 1. And then that means that we can wrap the rand with a fit01, because we know that this rand is producing values between 0 and 1. And then we can pick the min and max outputs of this entire expression. And for that, I'm going to do a minimum generations of 3 and a maximum amount of generations of 5. So at the moment, we're getting a number of 4, but then for each snowflake, we would get a different value. So that's one thing we can randomize. Another thing I might like to randomize would be something that affects both setups, and that would be the amount of divisions we have here. So we get slightly more complex snowflakes and then slightly more simple snowflakes. So to do that, again, to save us some time, I'm just going to copy this expression and I'm going to paste that into our division parameter here. Set the min and max amount of divisions we want. It's probably not 3 and 5. We probably want a minimum of 6 and then a maximum of 10. Now, the way that this setup works is that we mirror a segment and then we copy it over. So that kind of requires us to have an even amount of divisions. So to make sure that this number is always going to be even, we are going to be using a round expression, which we can add at the front. And then we're going to divide this output by 2. And then if we close the brackets and then times this round expression, which essentially rounds to the nearest integer, by dividing by 2 and then timesing by 2, we are essentially always making sure that we have an even number. Great, I reckon that's enough randomization for each setup. Now, what I'd quite like to do is randomize which setup we're going to be using. So to do that, I'm just going to pop down a switch. And then this switch is randomly going to pick between 0 and 1. So to do that, we're just going to quickly copy our iteration number, paste that into there. And then I'm going to randomize that. So we're getting an attribute that's between 0 and 1. And then we just want to round to the nearest integer. So now that we're randomizing a few key attributes, you could keep adding this to other things that you wanted to play with. For example, maybe you could randomize the element size, or maybe the amount of fractaling that you get in the noise, etc. But now I'm just going to say that's enough, and I'm going to quickly show you that this works with more points. So if I just pop down a grid, and at the moment it's 10 rows, 10 columns, which gives us 100 points. I'm just going to lower that so we have 16. And I'm just going to leave the size 10 by 10 for now. Now, just to quickly speed up this whole setup, we're just going to turn off voxel mesh If I plug this into our for each loop and visualize that, you can see at the bottom it's running 16 times. And we have 16 completely unique snowflakes. So the next thing we're going to do is set up a very basic Popsim that resembles something like falling snow. So if you don't know how to do that, then I'll show you now. If you do, then you can skip to the last part of the video. So I'm going to just drop down a grid and I'm just going to lift it up. And this is essentially going to be where our snow gets emitted from. So this is almost like our fake cloud. And then I'm going to drop down a subdivide after it. And then I'm just going to increase that subdivide so we have some more geometry to work with. Then if I drop down an attribute noise, this is essentially going to work as our density mask for our emission. So I can set this to density and then set that to float. And then we can't see what we're working with, so if we just hit this toggle here, we can then visualize density. I'm just going to increase this element size, and then in animation, I'm just going to hit animate noise. So making sure that we have real-time toggle on. I'm just going to press play. You can see our noise is animated. Next thing I'm going to do is drop down a scatter node. And by default, it's not looking for this density attribute, so I can just hit density. Now it's using that density as a mask to scatter our points. At the moment, it's not very visible, and that's because of this relaxed iteration. So if I decrease it, you can see that we have some high density areas and low density areas, which just makes the simulation more interesting. I'm just going to decrease the force count to something a bit smaller for now. Then we can feed this into a pop net. And if we dive inside our pop net, first thing we're going to do is change our source to be all points, the emission type. And we're also going to add some gravity. So we press play. See, we have some falling points. The next thing we're going to do is add a bit of variation, a bit of wind. So to do that, we can use a pop wind node, which we can just plug into here. And then here we have the amplitude, which is the amplitude for the noise that we're going to add. So I'm just going to increase that to something like 5 so we can see what it looks like. And I'm just going to decrease the roughness because we don't want this wind to be too jittery. We want it to be smooth. And if we add in a pop drag, it's just going to slow things down to make them look a bit less chaotic and a bit more sort of realistic. There's air resistance we can increase to something quite high. So if we press play, you can see we have some falling snow. So you can tweak these settings. First thing I'm going to tweak is probably increase the swirl size to something a bit bigger. And maybe my pulse length I'm also going to increase to something a lot larger as well, just so the noise isn't moving so much. And my pop drag, I think at the moment is too high. So if I press play, that'll do for now. You can, like I said, play around with these until you're happy with the type of snow falling that you have. If I go back up, I'm just going to decrease the amount of points we're emitting on each frame, just so it's a bit faster. We're still visualizing density, which is why these points are colored. So I'm just going to go back over and hit this toggle again, and it's disabled it. So now we have our simulation. We then need to set up these points to have the attributes that a copy to point will look for. So if you followed my dust tutorial, then you probably know what's coming. So copy to points node, first input is going to be our snowflakes. So at the moment we're instancing our snowflakes on a grid. We need all of our snowflakes to be at the center. A few different ways we can do that. The easiest way would be to just use a line stop, which I've set a length to 0, and then this parameter will just control how many unique snowflakes we have. So I'm just going to have 10 for now. So they're all at the origin, which is what we need. And then the second input is going to go into our pop net. So the first thing we're going to enable is our packet instance, just to make things a bit faster. If we visualize what that looks like at the moment, you can see that our snowflakes are massive. So the first thing we're going to control is our P scale. So we just drop down an attribute randomize. We can call it P scale. And then the attribute name is obviously going to be P scale. Dimensions is 1 because this is just a float. And then our max and min value, we're going to set to 0.5 and 1. And then this global scale is what we're going to use to set the overall scale of these snowflakes. So something quite small, I think. 0.5 is good for now. So we're not randomizing at the moment our snowflakes. So to do that, we need to be using the attrib from pieces node. Which we're going to drop here. So the first input is going to go into our popnet, and the second is going to go into our collection of snowflakes. So this node needs an attribute to be unique for each snowflake. So to do that, we are going to be using an attrib create. And then we're going to call this attribute name. And then the value is going to be, again, the current iteration number, which we can copy and paste in from here. So now in our attrib from pieces, we're going to be looking for that name attribute that we just set. And then if we plug our copy to points in here, on our copy to points, we can then look for the piece attribute name. Now if we visualize our copy to points, you can see it's randomly selected one of our snowflakes. So on our attrib from pieces, we can shuffle them up. Also setting the mode to random is probably going to help. The next thing we need to make sure we enable is this source points ID attribute, because our snowflakes will eventually die. If you dive inside here, you can see that in the birth tab, we have a life expectancy, which you could probably decrease to about 3 seconds. Or increase it if your snow is falling a bit slower. So when they die, it's going to reset the point numbers, and that's obviously going to change the seed for the selection. But by using this ID attribute, which we get out of the sim, it's going to stay unique for each point and not change throughout the shot. So we also need to enable that in our attribute randomize. In the options tab, the seed attribute we need to tick, which is by default looking for this ID. So the next thing we're going to do is add a bit of rotation. So to do that, we're just going to copy in this attribute randomize, and then we're going to initialize this n attribute. So the global scale can be 1. Again, making sure that this is ticked for the seed attribute. And then our dimensions is going to be 3. And we can set this back to 0. Next, we're going to drop down our wrangle. And we're going to call this wrangle orient. And this is where we're going to use a bit of vex code to set our orient to be moving throughout the shot. So to do that, the first thing we're going to do is initialize a float that we're going to call angle, and then we're going to set this angle parameter to be equal to at frame, which is going to grab the current frame number. And then the first thing we're going to do is multiply that by a attribute we're going to call global mult, or rather global speed might be a bit more intuitive. So that's our global speed. Then we're going to multiply that by a fit_1 function, which inside is going to be giving us a random value between 0 and 1, which is going to be unique for each ID. And then the min and max of this rand is essentially going to be our min mult speed and our max mult speed. So for now, I'm just going to set that to half speed and 1. So hit this, it's going to initialize our global speed toggle that we've got here. So we can just set that to something small like 0.1 for now. Then on the next line, we're going to initialize that orient attribute, which is the one that this copy to points is looking for to set the orientation of each snowflake. And then we're going to equals that to the quaternion function, which takes in that angle attribute that is changing throughout time. And then that n attribute that we set before in here. Then if we set up, which is another intrinsic attribute the copy of the points is looking for, to n, we can see that suddenly our snowflakes have shifted. And then if we press play, you can see each snowflake has got a bit of spin. So something that I've noticed is that if you set the mode to random, the snowflakes will actually change if one of them dies, and that is because if we unlock this node and dive inside, you can see that the random attribute randomize here doesn't have this seed attribute enabled, which is unfortunate, but we can just quickly enable that. And if we go back up, you can notice that it's no longer switching. So that's only if you wanted to use the mode random. So this is now ready for rendering. The next step would be to apply materials and then set our scene up with a camera and some lights. If you're unsure on how to do this with Mantra, then check out one of my other tutorials, such as the atmospheric dust. I hope you found this tutorial useful. Thank you for watching.